Hello, friends. Today we're going to dive into the most mysterious and scary part of the universe black holes. What is it exactly? Black holes are places in space with such a strong gravity that even light cannot leave them. Imagine a huge star that has exhausted its nuclear fuel shrinks to an incredibly small size, smaller than an atom, but with a mass that can be equal to millions or even billions of suns. And this is how a black hole is born. But how does it work? And what secrets do they hide? Let's figure it out step by step. First, what is the gravity of a black hole? It arises because the entire mass of the star is concentrated in a tiny object. In the center of a black hole, according to theory, there is a singularity, a point with infinite density and zero size, where our laws of physics simply cease to apply. Around the singularity, there is an event horizon, an invisible line beyond which you cannot return. If you get close to a black hole, its gravity can tear you apart before you even reach the event horizon, a phenomenon called spaghettification. Your body is stretched out like spaghetti because of the difference in gravity between your head and feet. It sounds scary, but it's the reality of space. But are all black holes the same? No, there are several types of them. There are stellar black holes that form after the collapse of large stars. Their mass is usually 10 times greater than the mass of the Sun. Then there are supermassive black holes, such as the one in the center of our Milky Way galaxy, where Sagittarius A star is located. Its mass is about 4 million solar masses. There are also hypothetical intermediate black holes, whose masses lie between stellar and supermassive, and even tiny primordial black holes that could have been formed as a result of the Big Bang. Scientists are still debating how exactly they appear, but this makes black holes even more interesting and mysterious. One of the biggest mysteries is what happens inside a black hole. We know that light can't escape, but is there anything other than a singularity? Some scientists suggest that black holes may be portals to other dimensions or even other universes. This sounds like science fiction, but string theory, quantum mechanics, and Einstein's general theory of relativity provide the basis for such ideas. For example, there is a hypothesis about wormholes, tunnels into space-time that could connect different points in the universe or even different realities. Who knows, maybe black holes are the door to the multiverse. Of course, these are still just theories, but they make us think about the limits of our understanding. Another interesting fact is that black holes can eat stars. If a star flies too close to a black hole, its gravity will tear it to pieces and then absorb the material. Astronomers have already observed such events through telescopes such as Hubble, Chandra, or the Event Horizon Telescope. It looks like a real space thriller. By the way, when material falls into a black hole, it forms an accretion disk, a hot, shining spiral that emits X-rays and even gamma rays. This is how we can see black holes, although the event horizon itself remains invisible. These accretion disks are like lighthouses that help us detect black holes in the far reaches of the universe. Do you know about the Hawking radiation? Stephen Hawking proposed that black holes are not completely black. They may slowly evaporate, releasing particles due to quantum effects near the event horizon. This is called Hawking radiation, and it means that black holes can eventually disappear. But this process is so slow that even the smallest black holes will take billions or even trillions of years to evaporate. This is another mystery that scientists are trying to solve because Hawking radiation calls into question the law of information conservation. What happens to the information that falls into a black hole? Does it disappear forever, or is it stored somewhere in a quantum form? These questions still have no definitive answer. Black holes also play a key role in the evolution of galaxies. Supermassive black holes at the centers of galaxies, like Sagittarius A star, affect the movement of stars, gas, and dust around them. They can regulate how new stars form and even affect the shape of the galaxy itself. For example, active galactic nuclei are galaxies where a supermassive black hole actively absorbs material, ejecting powerful jets of energy that are visible for millions of light years. Without black holes, the universe could look very different. Perhaps galaxies would not have the structure we see now. But how do we study them at all? Modern telescopes, like the Event Horizon Telescope, allow us to photograph black holes. In 2019, scientists first captured an image of a black hole in the galaxy M87. It was a dark spot surrounded by a shining ring of light that is formed due to the curvature of spacetime. And in 2022, we imaged Sagittarius A star, our own supermassive black hole in the center of the Milky Way. These images confirmed Einstein's theories about general relativity, but also raised new questions. For example, why do some black holes rotate at breakneck speeds while others are almost stationary? Why do their accretion disks have different brightnesses? Could black holes be dangerous for the Earth? Fortunately, the closest stellar black hole we know of is located tens of light years away, so there is no need to be afraid. But if a black hole suddenly appeared closer, for example in our solar system, its gravity could cause a catastrophe, disrupting the orbits of planets or even absorbing the sun. Fortunately, the chances of this happening are minimal, because black holes are formed as a result of very specific cosmic processes. So what do we really know about black holes? Probably not much, but each new discovery brings us closer to unraveling their mysteries. Scientists continue to investigate how they form, what happens inside, and whether they can be the key to understanding the nature of time, space, and even reality itself. For example, there are theories that black holes may be related to dark energy or dark matter, two of the other great mysteries of the universe. If you're interested in learning more about new space missions studying black holes or the latest theories in physics, please like, subscribe to the channel, and write in the comments what other secrets of the cosmos you're interested in. See you in the next video.